Have you ever stopped to consider exactly what kind of water was used to grow the food sitting in your refrigerator right now?
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello and welcome to Dr. Mercola's Cellular Wisdom. Today we are going to navigate some murky waters, quite literally. We're doing a deep dive into the hidden connection between water quality, modern agriculture, and ultimately our own health. We tend to think of water as, just water. It's either red or it's not. But some fascinating new research suggests it's way more complex, especially when we look at how our food is grown.
That's right. Great to be here. This is one of those topics that really sits at the intersection of environmental management and our personal well-being. The research we're digging into today shines a light on something we probably never think about.
Right.
And that's the specific type of treated wastewater used in agriculture.
Okay.
So our mission today is to understand how these microscopic dangers, we're talking about fecal bacteria and antibiotic resistance genes, can essentially hitch a ride from a water treatment plant all the way to the fresh produce on a grocery store shelf. Okay, let's just unpack that immediately, because you just said fecal bacteria and fresh produce in the same sentence.
I did.
And that's a combination I think most of us would prefer to avoid completely.
It's an uncomfortable reality, I know, but it's one we need to face. We have this image of farms as these pristine, natural places.
Sure.
But the reality of modern resource management is, well, it's a lot more industrial.
So this research, what exactly were they looking for? I'm guessing they weren't just testing tap water from a kitchen sink.
No, not at all. They were looking specifically at treated wastewater.
Okay.
In agriculture, especially in places where water is scarce, think California, parts of the Mediterranean reusing wastewater is a really common practice.
It makes sense from a resource standpoint.
It makes a lot of sense. You treat the water, then you use it to irrigate crops. It's the ultimate form of recycling, really.
Right. Keep the cycle going. Don't waste a drop.
Exactly. But what the researchers wanted to find out was whether the treatment methods we rely on are actually effective at removing the biological threats. So they didn't just test the water. They tested the vegetables grown with that water to see what stuck to them.
And I have a feeling, based on the title of our deep dive, that the answer was not entirely effective.
That's putting it mildly. The researchers found a really stark difference depending on the level of treatment. The shocking discovery, the story at a glance, if you will, is that secondary treated wastewater is nowhere near as clean as you might hope.
Secondary treated. Okay, we'll get into the definitions in a second because that sounds technical. But first, what did they actually find?
Two main things. First, as you mentioned, fecal bacteria.
Which is obviously a massive red flag for anything that touches our food. That is gross.
Precisely. It indicates the sanitization process just wasn't complete. But the second finding is, I think, maybe even more alarming because it's invisible and, you could argue, more insidious.
Which is?
They found antibiotic resistance genes.
Resistance genes. Okay, hold on. I understand finding bacteria. That makes sense. It's a living organism, a bug you can see under a microscope.
Right.
But finding genes, that sounds like finding the blueprints rather than the building itself.
That is a brilliant analogy. Think of it exactly like that. The bacteria are the soldiers. They're the ones that can invade your system.
Okay.
But the resistance genes, those are the instructions on how to build the armor.
The genes are the manual.
Exactly. And here's where it gets really interesting and a little scary. Even if you manage to kill some of the soldiers, if those instructions, those blueprints for armor, are floating around in the water and they land on our food, they can be picked up by other bacteria.
Wait, so a bacteria that wasn't resistant before can just, pick up these genes and become resistant, like downloading a software update?
Essentially, yes. It's a process called horizontal gene transfer. It's like me handing you a book. You didn't write it, but now you have all the information inside it. So if those blueprints for antibiotic resistance land on, say, a piece of lettuce, and that lettuce enters your system, the bacteria that are already living in your gut could potentially pick up those blueprints.
That is both fascinating and terrifying. So it's not just about the bug itself, it's about the genetic material that can teach other bugs how to survive our medicines.
Correct. It points to a mechanism for transfer that most people just don't think about. We worry about getting sick from a specific pathogen, but we rarely worry about consuming the genetic code that allows bacteria to defeat our medical treatments.
And this secondary treated wastewater is carrying both?
Both the soldiers and the blueprints for their armor, yes.
So we have this contaminated water. But the research makes a distinction, right? It's not all treated water that's the problem. We need to clarify this difference between secondary and tertiary water.
Yes.
Because to the average person, treated water just sounds treated. It sounds like it should be safe.
It is a critical distinction. It's really the hinge that this entire thing turns on. If we don't get the difference between secondary and tertiary, we miss the whole point and the solution.
So walk us through it. What is secondary treated wastewater?
Secondary treatment is a pretty standard step. It generally involves using biological processes to remove dissolved organic matter.
Okay.
You can imagine these huge tanks where they pump in air and use good bacteria to basically eat the bad stuff in the sewage. It gets rid of the solids, it cleans the water to a point where it looks pretty clear.
So visually, it might pass the eye test. If I saw a glass of it, I might not, run away screaming.
Often, yes, it wouldn't look like sludge. But biological safety isn't about what you can see. The research clearly identified this category secondary treated water as the culprit.
And it still has the bad stuff in it.
It retains those fecal bacteria and, crucially, those resistance genes we were just talking about. It cleans the water of visible stuff, but it doesn't sterilize the genetic history of what was in it.
So it's clean-ish, but not really clean. Good enough for what? Watering a golf course, maybe?
Exactly, or for dumping into a river where it gets heavily diluted.
Yeah.
But spraying it directly onto food, that is a completely different ballgame. Now, compare that to tertiary treated water.
Okay, so what's tertiary?
Tertiary treatment is the next level up. It's the polishing phase. It involves things like advanced filtration, forcing the water through membranes with pores so tiny that bacteria literally can't fit through.
Wow.
It also involves aggressive disinfection, often using chemicals or UV light, to just scramble the DNA of anything that's left.
So this is a full-on physical and chemical assault on the contaminants.
Precisely. And this is the good news buried in the data. The research found that tertiary treated water performed much, much better. In fact, they noted that it behaves a lot like potable water.
Potable as in drinkable.
Exactly. Safe for human consumption.
So we have a night and day difference here. Secondary treatment leaves behind bacteria and these resistance genes. Tertiary treatment scrubs it clean, making it basically like tap water.
It's a massive gap in safety. And this is why the details are so important. If someone just says, we use treated wastewater, you're not getting the whole story.
Is it secondary or tertiary?
And the answer to that question determines if you're spraying safe water or a cocktail of genetic resistance onto the food.
Which leads us directly to the food itself. Because we're not just treating this water to put it back in a river, we're putting it on the fields that grow our produce.
That's the connection. The research explicitly links this water to fresh produce.
This is the aha moment for me. We focus so much on soil quality or pesticides, but the water itself is a delivery system.
It is.
So if a farmer is using that secondary treated water, the fresh produce becomes a vehicle for these contaminants.
Yes, and think about the nature of fresh produce. The texture of a spinach leaf or the surface of a strawberry.
It's not smooth. It's got all these little nooks and crannies.
Exactly. And unlike a sealed package, fresh produce is exposed. And if that exposure is to water-carrying resistance genes, those genes are deposited directly onto the surface of the food. When the water evaporates, what's left behind?
The contaminants. The genes.
The residue stays. And the research noted that these contaminants can be really hard to remove once they're on there.
And here's the kicker for anyone listening.
Yeah.
You cannot see antibiotic resistance genes on a head of lettuce. You can't smell them. You can't taste them.
That is the invisible nature of the threat. If you see dirt on a carrot, you wash it off. But we're talking about microscopic genetic material.
So biological safety is entirely dependent on the method of water treatment.
The treatment method is the deciding factor. It's a gatekeeper.
It really challenges how we look at the produce section. You see these beautiful rows of vegetables and assume they're pristine. But this research validates a serious caution about raw foods.
It does. And to be clear, the risk is specifically with fresh produce that might be eaten raw. If you're cooking your vegetables, you're changing the whole equation.
Right, because heat acts as a sanitizer.
Exactly. High heat kills bacteria. It destroys the integrity of that genetic material. So the risk profile changes completely when you cook your food. The danger here is specifically the pathway to fresh, raw produce.
So if you're relying on raw salads or uncooked greens, you're basically just trusting that the water used was tertiary. not secondary. You're rolling the dice.
You're trusting a supply chain process that is rarely transparent to you, the consumer, and given that secondary treatment is much cheaper than tertiary.
So it's probably more common.
It's a bet that I personally wouldn't want to make with every single meal.
It really reinforces the idea that cooking your food isn't just about taste or digestion. It's a critical safety step. It's a firewall.
It is the ultimate firewall.
I want to circle back to that phrase, antibiotic resistance. We hear it a lot. It's a buzzword. Why is it so important here? Why should you at home care if a gene on your spinach is resistant to antibiotics?
This is where we have to connect the dots to the broader biological crisis we're facing. Antibiotic resistance is the ability of bacteria to survive the drugs designed to kill them.
The superbugs.
The superbugs. It turns a manageable infection into a life-threatening one. And we usually hear about this in the context of hospitals or maybe in livestock.
Right, those are the breeding grounds we think of.
But this research shows an environmental loop that's just as critical. So you have wastewater from our homes and cities.
And that water contains everything we excrete.
Everything, including traces of antibiotics we've taken or resistant bacteria from our own bodies.
So the treatment plan becomes this giant mixing pot.
A giant incubator, really. Now, if that water only gets secondary treatment, which we've learned is not good enough, it then goes on to the crops.
And the crops carry the resistance genes.
And when we eat those raw crops, those genes can potentially enter our own microbiome.
So it's a cycle. We excrete it, we fail to clean it properly, we put it back on our food, and we eat it again.
That's the cycle. It's a disturbing image, I know. It implies the water cycle isn't just moving H2O around, it's moving information. It's moving genetic data.
And in this case, dangerous data.
It allows resistance that developed in one person to potentially end up on the food of another person. It closes the loop in a way that just amplifies the danger.
This really shows why we have to care about the specifics of the agricultural process. It's not enough to just say, support agriculture.
That's the key. Knowledge is the only defense here. Knowing that tertiary treatment works is reassuring. It means the technology exists to do this safely.
So we're not doomed to contaminate our food.
Not at all. We just need to ensure that the rigorous standards, tertiary standards, are the ones being applied to food crops.
But I imagine the gap between we have the technology and it's being used everywhere is probably pretty wide.
Unfortunately, yes. Secondary treatment is cheaper, it's less energy intensive, so there are economic pressures pushing people toward water that isn't quite up to that tertiary standard.
Which brings it all back to us. We're standing in the grocery store aisle. We don't have a water quality report for every tomato.
No, we don't.
We don't know if the farm used tertiary or secondary water.
And if you can't verify that water source, knowing that raw produce is a potential carrier, it just changes your risk calculation.
You mentioned cooking, but what about just washing? If I scrub a carrot really, really hard, does that solve the problem?
It helps, certainly. Washing removes surface dirt and some bacteria. But remember those nooks and crannies we talked about?
The hiding spots?
Yes. Microscopic genes can lodge in the texture of the plant. There's even research suggesting some bacteria can get inside the plant tissue through its breathing pores.
So the call is coming from inside the house.
In a way, yes. If the bacteria are internalized, no amount of scrubbing is going to wash them off. That's why the emphasis really has to fall back on cooking. Cooking addresses both the internal and the external.
That's a powerful takeaway.
Yeah.
We have this idea that raw is better or raw is more natural, but in an industrial system using treated wastewater, raw might just mean exposed.
Exposed is the perfect word. You're exposing yourself to the environment that food was grown in. And if that environment included secondary wastewater, you're exposing yourself to that water's entire history.
Let's zoom out. I want to revisit the tertiary water. The study said it acts like potable water. Could we solve this problem tomorrow if everyone just switched?
In theory, yes. The science suggests that tertiary treatment breaks that chain of transmission. It removes the bacteria, and crucially, it deals with the genetic material.
So the pathway would be closed.
If all agricultural water reuse for food crops was held to the tertiary standard, this specific pathway for spreading antibiotic resistance would be largely closed off. Yes.
That's actually very hopeful. It means we're fighting an infrastructure and investment issue, not some unbeatable enemy.
Exactly. It's a solvable problem. But it requires us to recognize that clean enough isn't actually safe when it comes to biology. Secondary treatment might look clean enough,
but it's not.
For food production, the science is telling us clearly, no, it is not safe enough.
And that distinction is what makes this so important. Before this, I would have just thought, oh, recycled water, that's good for the environment.
And it is. We absolutely should recycle water, especially with water scarcity issues around the globe.
Right, but the nuance matters.
Nuance is everything. Blindly cheering for water reuse without asking to what level of treatment is dangerous. We need to be advocates for safe reuse, and that means tertiary.
It's funny, we obsess over macronutrients, carbs, fats, proteins. We look at the back of the box. But we rarely think about the microscopic genes tagging along for the ride.
We're entering an era where we have to think about the genetic information in our environment. Understanding that antibiotic resistance can spread through something as mundane as watering lettuce, that really changes your perspective.
It sure does. It makes you realize that the boundaries we draw between the bathroom, the treatment plant, the farm, the kitchen are a lot more porous than we like to think.
They are biologically linked, and if we ignore those links, we do so at our own peril.
Okay, so let's just recap the key points here. We have research that looked at treated wastewater being used on crops.
Correct.
And it found that secondary treated water, the good enough stuff, was actually contaminating crops with fecal bacteria and antibiotic resistance genes.
A clear failure of safety.
But the high standard tertiary treated water was found to be safe, basically like drinkable water.
A clear solution.
The danger is that these contaminants, especially the genes, are invisible, and they turn fresh, raw produce into a carrier for resistance.
Which then feeds back into the global problem of antibiotic resistance, threatening our ability to treat infections down the line.
And the most practical takeaway for you listening seems to be, understand that raw produce carries this specific risk, and that cooking is a reliable way to mitigate it.
Absolutely. Awareness is the first step. And practically speaking, when you can't verify the source of your food's water, heat is your best friend.
It's a heavy topic, but it really does empower us to ask better questions about our food system. Instead of just asking, is this organic? Maybe we should be asking, what kind of water grew this?
It's a question that needs to be asked a lot more often.
Now, here's where it gets really interesting for you, the listener. We know that tertiary water is safe and secondary water is hazardous. That's the science. But here's the question you have to ask yourself next time you're shopping. Do you actually know which one is being used on the agriculture you support? The label tells you where it was grown, but it doesn't tell you the water quality report. It's something to think about. Thank you for listening to Dr. Mercola's Cellular Wisdom. See you in the next episode. Looking for trusted health wisdom you can hold in your hands? Discover the life-changing books of Dr. Mercola at joyhousepublishing.com. These titles bring decades of natural health research into practical steps for better energy, stronger immunity, and clearer thinking. Take charge of your health with guidance rooted in science and experience. Visit joyhousepublishing.com now and claim your bonuses while they are available.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.